This video is about soils, and it should just be a reminder to you about the stuff you learnt in geotech. Geotech is very important, obviously, in earthworks because it directly relates to uh, the soils that we're working with. That is why you learn geotech, because one of the main materials we work with as civil engineers is soils. So there's different types of soils. There's coarse soils such as sands and gravels. Um, they are non-cohesive or cohesionless, so those are other words for them as well. In other words, when you pick it up, it's a whole lot of grains rather than one gobby mass. There's fine soils. I call them fine soils. Other people call them cohesive soils, which means they're held together by internal attraction. So that's like clays and silts. So you squeeze it and it comes out as one piece. And then there's organic soils, topsoils and peats. Most sites you go to will have a topsoil layer. Topsoils and peats are not very good for constructing on, so normally what we do is we remove it and then build on the underlying cohesive or non-cohesive soils. So the topsoil, or if there's peat, we need to remove it. Sometimes you've got no choice, you're having to build on organic materials, and in which case you've got some serious stabilization to do if you're going to build a structure on top of it. So if we can, you remove organic soils. If you can't, you've got some extra cost to stabilize them. The states of the fine soils, so in Auckland especially, most of our soils are clays and silts, and so it's really important that you have a really good understanding of how they work. You'll be aware as you add water to them, they go from solid to liquid. So solid material is like baked clay, very hard. All the soil particles are arranged in a very strong matrix. There's hardly any water in the soil voids. Semi-solid, there's a little bit more water in the voids. Plastic, there's more water still, and so it can be molded. And then liquid, it's usually totally saturated or close to saturation. So in other words, the voids are almost totally full or totally full of water, and the soil particles aren't edge to edge, so it has the consistency of a fluid, which is obviously not very good if you're trying to build something on top of it. So what we're trying to do in earthworks is work with plastic semi-solid material, working around that optimum moisture content. So looking at the soil phases, there's the gas phase, the air if you like in the voids. There's the solid phase, which is the soil particles. If the soil particles are all in contact with each other, then that's going to be a stronger soil than if they are being forced apart by the voids or the water in the voids, the water pressure, the pore pressure sort of keeping them apart. So the soil phases is really quite important. The difference between what the water content of the soil, the moisture content, is a very important measure of soils. So the soil properties, it's really important that you this is just a broad look. Each individual soil has its own properties, but generally the drainage in the coarse soils is quite good. So if it rains, the water just drains out of the sand or the gravel, and you can start running trucks on it after the rain stops. Clays and silts, however, hold the water in there, and they go from being maybe semi-solid or plastic down to being very plastic, and so you can't run trucks over top of it because they just sink into it. So the rain, when it gets wet, it doesn't drain very quickly, it doesn't dry out. That water stays in those voids, it stays in that plastic, highly plastic state, and oftentimes you have to dry it out before you can start work again. Sediment and consolidation happens quickly, so you'll recall that sediment and consolidation comes down to how fast the pore pressures can equalize to increased loads. So you put a load on top, the pore pressures increase because of that load, and it needs to dissipate. As it dissipates, the soil settles over time. It happens very quickly in sands and gravels because the soil, the water in the soils is able to get out of the voids very quickly. In fine soils, especially clays, it takes much longer for them to sort of get out, and therefore the consolidation and settlement can be much slower, can be up to years in some clays, and as we'll see later on, there are ways of accelerating that consolidation and settlement, because obviously when you build a structure on top, if it's still settling, then after a year or two you may have differential settlement. It may be lower than what it's supposed to. So long-term settlement and consolidation is a concern and something we want to address when we're doing the construction. Slope stability. Coarse soils normally stand at the angle of repose, usually 30-40 degrees, and the only thing that's holding them up is the internal friction. Fine soils varies considerably. Sometimes you can have fine soils standing almost vertical. Sometimes they can't even get, they'll start sliding after 10-20 degrees. So it varies considerably. You need to be aware of what the angle at which the soil you are working with is stable, because obviously the last thing you want is slips happening on your site. And trafficability, after it rains, how soon can you get the trucks back on? How soon can you start working? With sands and gravels, almost immediately, because they drain so quickly. With fine soils, it can take a longer period of time, and they're soft and they're slippery, so it can take time after they're raining, which is why one of the decisions you need to make when you're constructing is, do I have gravel on my haul road? If I'm constructing in clay country, do I build a gravel haul road, spend that extra money, but if it rains then I can still get my trucks in and out of the site. Compaction. This hopefully is something that you are well aware of, the standard compaction curve for a fine soil. So if it's too dry, so this is the density compared to this moisture content. If it's too dry, it can only compact to that soil density. The soil density is directly related to the shear strength, so the more dense it is, the stronger it is. So it's not very strong here at the dry end, because there's no lubrication between the particles for them to rearrange themselves into a more dense and strong shape. On the other side, if there's too much moisture, there's going to be pore pressures resisting the soil particles getting into a strong, stable structure. So there's a point, that moisture content, the optimum moisture content, where there's just enough lubrication for the soil particles to arrange themselves into as dense a state as they possibly can, but not too much so that it prevents them from arranging themselves into that. So you should be aware that when we're compacting, we're trying to make sure that our soil that we're compacting is in this particular area here. It doesn't have to be bang on to the optimum moisture content, but it has to be within 2, 3, 4% of that to enable you to do the compaction properly.